Live. Okay, so today, just like yesterday, we are going over two different lessons. Yesterday was looking at linear equations, learning how to graph them using intercepts, and then just comparing two different linear equations. You know, one has a steeper slope, one has a greater slope, a less slope, different y-intercepts. We had a lot of things we can talk about comparing. Today is just first getting everything, remembering how to do exponentials. Remember, these are exponentials, our growth rate, our decay rate. And then we have to learn some vocabulary to compare the two graphs, okay? So we're going to use a table. You don't have to use or do anything tricky. We'll just use a table. And the key for today is going to be, one, find the asymptote, okay? Which I don't mind if you abbreviate like that. Asymptote is a line that our function will go up to but never cross. So you see this line right here, it's at y is equal to 0. When y is at 3, 2, 1, 0, we're on our y-axis, so this is y is equal to 0. And you see that the function goes down but never quite touches that line. Okay? So we would call this our asymptote. The asymptote is one of the forms that helps us see where the function is. So I look here, the asymptote is that y is equal to 0. That's where this function is kind of leveling out but never touching it. It's really strange. Abstractly, it never touches it. The in behavior, where does the graph go? Go in this direction? Does it go up? Does it go down to the asymptote? We just got to describe this. Okay, so this is how I would describe this. As x gets bigger, so when I get over here towards the larger x values, the function approaches y is equal to 0. It approaches the asymptote. Okay. The other side, so you can even write that this way. You can say the in behavior in this direction, it is approaching, approach y is equal to 0. That's fine for talking about in behavior. Over here, what's happening over here? In behavior, in this direction, as x gets smaller, the function approaches positive infinity. It's going up. So essentially, when you have, when you get into math 3, you're going to have functions that are like this. Right? And you'd say the in behavior on this side, as x gets larger, is going towards positive infinity. The in behavior over here, as x gets smaller, is going towards positive infinity as well. So it would just tell you if they're both going up, or one's going up and one's going down, or vice versa. Okay, so in behavior is kind of a loose term, and that's how we're going to describe it. All right, so let's look here. Next, so when we're comparing, we're going to talk about the asymptote. We're going to talk about in behavior. We're going to talk about the y-intercept. Those are the main things we need to talk about. Okay. Now, let me add one thing to this. This is new. Actually, I'm going to add two things. I'm going to add this right here, plus k. This is our asymptote. It's also our shift. It's our shift up or down. Okay. So this is kind of key today. That is plus k. That is if the entire function is shifted up, shifted down, how it's shifted, right? Let's see. So if we're going to graph this and talk about those components of the graph, let's look at this problem right here. And actually, I'm going to have you do this. I'm going to have you add 1 to it. Plus 1. Plus 1. Everyone do that? Caden, you got that? Plus 1. I just changed it. I want to make sure you got that example. All right. So we got to graph this. We got to use a table. Let's go ahead and put our graph right here. And let's see what we can do here. What number? Well, first off, when you're graphing using a table, the y-intercept is just your a value. What is our a value? The initial value. Since this is time, right? This is time. Since we're at time is equal to 0, aren't we at the initial? We're at the start. At time is equal to 0, we're at the initial. So watch. Right away, I could say, well, when time is 0, guess what? We have 0. Oh, well, we don't have the initial. What is, when we plug in 0 for x, what do we get for y? Tell your neighbor. Tell your neighbor. What do we get for y when we plug in 0 for x for this? What you think? What do you think? Yeah? All right, Quinn, what do you think? 4. You guys get 4? Anything raised to the 0 is 1. Anything raised to the 0 is 1. You just have to remember that's like the weird rule of math. It is one of the weird ones. So this is 1 times 3. 3 plus 1? 4. All right, what other number should we plug in? Here's what's going to help you guys. You plug in 0. That's perfect. We got 0, 4. 1, 2, 3, 4. I know that's where the y-intercept is. Now, I want to see what's happening way over to the right, way over to the left. Sorry, right, left. So what's a number way over to the left we can plug in? I like this. So we're going to do one that isn't so far away, but I want you to do one that is far away, -10. Because you want to see what it's getting close to. If it's getting close to that asymptote, then you know that you want to look pretty far over to the side to see if it's getting close and how close. What should we plug in over here? Let's do 1 because that's easy. And then, what do you think? Something way over here? 10 because we did -10. Let's do 10. All right. So we're going to go 1 and 10, and then -1, -10. These aren't in order, but that's okay. Let's do 1, just mental math. 1. 1.25 raised to the first power, 1.25. You have $1.25 and you multiply it by 3, you got $3.75. Take $3.75, that's all this now, plus 1? $4.75. We'll get plenty of chance to do some calculator work next. Okay, so let's plug in 10. We're going to y is equal to 3 times 1.25 raised to the 10 plus 1. So on a calculator, which there's a few up here, grab your calculators. Grab that one. You don't have one. Or this one. Who else? All right, guys, you gotta go to the 99-cent store and get a calculator because no, what is that? There's fires. That might be fire smell. Oh no, I can smell the cafeteria from here.
Yes. Hopefully the bell
please don't put the smoke. Don't put it in the doorway, guys. That's what they did last time. That's where the fire alarm went. You know what else? They were barbecuing right in the doorway. Yeah. That's why we lost like 30 minutes of our school day. Somebody did that. All right, here's how we're going to plug this in. 1.25. Write that. 1.25. You're going to push that little chevron button, or it might be this button. It's one of those two buttons. You're going to put in then 10, and you're going to put equal. That gives you your answer for that part. All right. Once you've pushed equal, it's in the calculator. It is the answer that you could then keep building off. So now do answer times 3 equal. Then you have the answer already set up. It's going to be the answer plus 1 equal, and that's our answer. You see the path? You getting used to that? I hope. Who feels confident? Yeah, Kate. Perfect.
Oh.
Now I want to know. I'm so happy that that's true. What is when we plug in 10 for x?
When you plug in 10 for x,
yes.
It's 9.3 something. I already did that. Yeah.
It's going up. You see, we just want to know what's going on over there. We don't have to know exactly what's going on. We know that at 0, it's here. At, let's see, at 1, it's about here. At 10, it's where? It's kind of like up here, I'd say. Let's put it right there. All right. And then, how about -1?
Okay, hold up. So, yeah, it's 28.9.
You were close, man.
I was close.
All right, I got to put this. I mean, obviously, I'm seeing that as we get x values that are greater, what is it going up towards? It's going way up there. I'm going to put it like way up here. All right, we'll talk about end behavior in a second. Let's go ahead and plug in -1. Let's say we get y is equal to 3 times 1.25, -1. It's going to be the same thing. You're going to do everything the same except for instead of 10, it's -1. Follow the same syntax. And let's see what we get. What did we get? Who's done on that? Jackie, what'd you get? 3.4. Looks like it's going down. What is it going down towards? We will see. We got our next point in there. -10 will help us. We don't know what's going on way over there. We plug in -10 now. This is calculator work. And without practice on the calculator, that's where the errors are going to happen as well. What will?
1.3.
Good. 1.3. I'm seeing that. My guess is that our asymptote is here at y is equal to 1. And we need to test that one more point. So we got it down to here. It looks like it's leveling out at 1. So how about somebody put in like -30? Let's see what happens with -30. Last one. So we're going to just plug it in one more time. -30. It's like really close to 1, right? Or it even says 1.
Add 1, it equals 1.
Yeah. 1.003. So I do want to put that because I want to show that in one direction as you get further from the origin. So -1, we're at 3.4. -10, we're at 1.3. -30, we're at 1.003. You see how I can figure out that it's getting closer to what? 1. If I were to put in -40, I probably would end up with, I'm just going to guess, 1.0003, right? It's getting closer and closer to 1, but never touches it because we've just deduced that this is our asymptote at y is equal to 1. That's our asymptote. Our asymptote, which I want you to label. And now let's just talk about end behavior. As the end behavior as x gets smaller, what does it approach? Y is equal to? Approaches y is equal to 1. Here is our asymptote. As this goes to the right, the end behavior as x gets larger over to the right, it approaches what? What's happening? Where's it going? Up, up, and away. Towards positive. Okay? So here are our 3 components. We have our asymptote. We have our y-intercept. We have our end behavior in both directions. The second lesson, all it's doing is saying, compare them. So you tell me, what's different between these? What's different between the really messy graph we just did and this graph? Name one thing for our candidates. Let's do it. Jackie. Okay, good. This one is increasing. This one is decay. It's decreasing. That's perfect. Nice catch. Anyone else? What's another difference? We just said that the first graph we did is increasing. This graph is decreasing. That's a good compare-contrast. What else can we compare-contrast? What else is different? Look at the 2 shapes. Isabel.
That asymptote is -2.
Good. versus,
Now it's 1.
that's 1. So that graph has the asymptote here. Down here it's at -2. Very good. Think about the third. That'll answer the phone. Can you guess it's a early release? C's from 3. Sure. Marcus, they need you in the front office real quick. C's from 3. Okay, perfect. Thanks. And then David, early dismissal. I don't think you need to bring your stuff. All right. I was waiting for that. Wait. Where's David from last week?
No.
Okay, and we don't have a David. I don't have a David in the class. I have David last period. Marcus is going to the office. And Magnolia. Okay. Great. Early dismissal. You expect that? Oh, okay. I think they said early dismissal, so why don't you go grab your stuff. Sorry again. What is the last thing that we could say about these two? Last thing. What else does it compare contrast? Look at the 3 things we talked about. Asymptote, end behavior, or the y-intercept. Nate?
Yeah. Asymptote thingy.
Oh, Isabel said asymptote already.
Oh, okay, my bad. The
Okay.
end behavior.
Yes. Genevieve.
The
The y-intercept here is at
3.
what? 1, 2, 3, 4. 4, 4. Over here? 0. Okay. Those are good too. We already talked about the end behavior in essence because we said this is increasing, so it goes down towards y is equal to 1. It goes up towards positive infinity. Here, as x becomes smaller, it goes up to positive infinity. As x becomes bigger, it goes to y is equal to -2. Okay. Thumbs up, sideways, down for graphing from a table. That's just calculator work. All right, how about comparing them? We're okay with comparing them? All right, we're suckers at that. Okay. All right, that's it. Okay, thanks for watching.